Okay.
Hello.
Hello, anything?
Sure.
Yep.
Memang 2 hours right day.
Yep. So today,
Oh, okay. Okay.
because Friday you got a test. So it's better to finish the 2 hours and then you can go and prepare rather than have another hour.
Oh,
Plan ahead.
oh,
If
good.
you find too stressing 2 hours, plan ahead and let me know earlier.
Yeah. Okay. Mm.
Okay, let's go to checkpoint. Any question else to ask? If not, let's go to focus.
Checkpoint no. Now only what finish do later.
Checkpoint, we have finished all, right?
No. I mean checkpoint can you just what just teach me what so then later do what.
Checkpoint, we haven't done yet, right?
No. What I mean is because today only you taught me what, so I haven't done yet.
No,
So no
potentiometer.
point going through that.
Potentiometer.
Potentiometer.
Hmm. Potentiometer is supposed to
15.5.
have done it. Wisdom bridge is not much. Potentiometer is the one I'm more worried about. If you don't do it, you lose it. Okay, you better do it now. If you haven't done it, no point in going so far.
If like that means can just have 1 hour. It's better.
No.
Not wasting time.
We won't let it change like that. Won't let it get away. The next hour we will start a new topic.
New topic.
Yeah.
You mean new chapter?
Yeah, new chapter.
Oh. Then okay.
I want to spend about half an hour for this one. No, you forget everything.
I thought you're going to do this chapter for the whole day. That's why I'm thinking.
No, I just want
Anyways,
to do exercise. Because you don't do exercise, you lose everything.
so focus or checkpoint.
Yeah, now on checkpoint, go and do it now. You haven't done it.
L1 plus L2 over L1 times 1.02. That's the answer.
This is checkpoint one.
15.5. Number one.
Is that right?
Yeah lah. That's how to do lah, because you have to compare between the two lah. Yeah.
Okay. Try this one.
Go back again. I think I missed something. Sorry. Yeah. Okay. Number 2. Number 2. I'm not sure.
That's why I say you don't try it out, you lose out. You're done in class already. Diagram shows a potentiometer circuit used to measure EMF of a thermocouple. Thermocouple is usually measured very small resistance in millivolt. Length of the slide wire AB is the wire is L. and its resistance is R. The internal resistance of the driver cell, this is a driver cell, is negligible, so you don't have to worry about it. The balance length is AC. Calculate the EMF of the thermocouple. This one trying to get you to derive the formula. Okay, you are given the length of AB is R. So you have to use it as a potential divider. You want to find the potential across AB. Previous one is you don't have to worry, right? The potential across XY is the same as the driver because there is no resistance here.
No resistance.
But in this case, you have the wire that got a resistance. So you have to find the potential difference across AB first. Because that EMF is not across AB, across R and across AB. So that's the reason why we are doing your VAB, right? VAB over that. It's just a potential divider formula. This is your R, AB is your R, and total resistance is R plus R. And you find your VAB. After you find your VAB, then you apply the potential divider formula to the thermocouple. Right? VAC is the thermocouple potential difference or EMF of thermocouple divided by VAB equals to your balance length X over that length AB L, and take your AB across and replace your AB with this value. Okay, that's the answer.
Okay, number 3.
Number 3 you cannot do.
No. Number 3, it's 1.50 volt.
Okay, let's see 1.05 correct or not. The circuit diagram shown below, the EMF of a cell is E1, and then 2 volt. Internal resistance is negligible, don't need to worry. Length of the slide wire PQ is 100 cm. When the slider S is open, the balance length is 75 cm. So it means that when this is open, you are measuring the EMF of E2. When the switch is closed, the balance length is 65 cm. So when you close the switch S, you are measuring the potential difference across 4, right? Or we call terminal potential difference. So when the switch is open, potential meter measures EMF of the cell, and you have your E2, this is your E2 over E1. As long as you can get the formula, you can solve it already. It's just your E2 is corresponding to PJ, E1 is corresponding to PQ, and cross multiply. Right? E1 is 2, PJ is total is 75, PQ is 100. Calculate out. Then internal resistance of E2. Okay, that's more challenging. What do you get? Find the potential difference across the forward versus 4 ohm.
S is close, so 65 or 100 times 2 lah.
So it's the same formula. Right? V across E1 is PJ over PD. E1 is 2. Balance length is 65 over 100. Then times 1.3. And after that, you have found the potential difference. You can find the current through this circuit there. Right? Remember, no current through here. The current is only through this circuit as well. So you got 1.3 divided by R is 0.325 ampere. And then use your resistance formula. Kirchhoff's voltage law at E2 equals to potential difference across here plus your IR here, right? Small resistance here. And R, take V across, get E2 minus V, and break the I down, put in your value, calculate. Can.
So that means we campur together lah, basically, right, sir?
Campur together is you understand what is doing, what is doing here. First thing you want to find the EMF of E2. Then secondly,
Yes.
you have to find the
Can't find the internal resistance.
across the 4 ohm. And then to
Mm.
find the internal resistance of this E2, you have to use this formula. So this formula have to find the current through the circuit first, step by step.
Mm. Oh, this is just process by process only lah. Then you
That's why you have to work through. You don't work through, you lose it. Right? Your book is quite good. It takes you through section by section. Sad tendency for you is you don't do your homework. No shortcut physics. Especially your syllabus, mainly calculation. It's just like maths. You don't do it. You want to study it, sorry. Very hard to pass. Okay, try the next one. It's more difficult already, more challenging. It's working backwards now. Not like what we have been doing. Start from E1. Start from E2. Find your potential difference across PJ first. Then after that, find a potential difference across EQ. Can?
So you use the V equals to IR formula, right?
You use the same formula, except that you have to find the potential difference across PJ first, working from here, not from there. From E2.
PJ is 3 lah. 3. So why E2 2 pula is 3?
Huh?
It's 3, you put 2.
E2 is 2.
That's resistance.
E2, oh, I got it wrong. Okay, sorry. Thank you. You go backwards. Right? Yeah, just using the length is proportional to potential difference, that's all. And VPJ over PJ. Same, you can do the other way around. Take the PJ down and PQ there, same thing. Then it's VPJ over PJ, that's all. And PJ equals to E2. It's no current flowing through, that's 3 volt. Put in your value. VPQ. You want this one? After you found your VPJ. So PQ is 100, PJ is 60. And VPJ you have known, 3 volt. Put inside there, you get 5 volt. Okay, so what is the internal resistance? And you forget about this lower circuit now. Concentrate on the upper circuit. Yep. And
The answer is 7.
that's it. So now you can forget about this lower circuit because there's no current flowing through it. Concentrate on that one there. So current through here is VPQ over resistance of PQ because you are given resistance of PQ. Right? There's a reason why we find PQ. Put in there, calculate the current. There are other ways to do it. Here's my way of doing it. 1 ampere, and use the formula for this circuit there. E1 is the potential across here plus the potential across the internal resistance. Put in your value. This one across is plus minus. Take your I down. Okay, good. This one.
Go ahead again, sir. Okay.
I can use this circuit to compare resistance if you want to. A bit more challenging, this one. What's the balance length? Yep. Find the potential across the 5 ohm. and connect to Y. The potential across this one using this circuit there. It's a potential divider. Yep, can.
Can I get like this one, sir? Dead end.
Potential divider. When you put across XY, then you're taking the output across this one. So it's 5 over the total resistance. It's just your V1 across here over the E2, that's all, which I put E. Then I got that. Then after that, I can do a potential divider. Right? This is my V1 now. Right? V1 is compared to this one, VPQ equals to PJ over 100. Okay, I can find my PJ, cross multiply. Right? V1, I've got that. VPQ, there's no resistance here. So VPQ is equal to E1 or E. That's what I'm doing. I got 50 cm. Can. First, look at this circuit separately. This is a potential divider across 5 ohm. Find the output across 5 ohm, which is this one. 5 over this total resistance. This is a potential difference across here divided by E2. Got that? Then after that, we got the potential difference across here. Now potential difference across here over the potential difference across this one is just the balance line PJ over PQ. Put the value inside and calculate. Now do part B.
Oh, okay. 8 over 10 equals to PJ over 100.
Same thing, that's all. Nothing much. PD across 8 ohm because it's 5 plus 3. When you put it across Z, you're just using the same formula. That's all. And repeat the same thing. Now it's called V2 instead of V1. Same formula. Work it out. 80 cm. Okay. Okay, try this one.
Back. Okay, number 6.
After that, we go to, I think I'll let you go to do the rest yourself. Let's go to do some focus question so that you are ready to answer question next week. So you haven't done it, you better go now.
Okay, number 6, last question. Number 6, no, right?
Number 1 can do.
Hello?
Yeah, number one can do.
Number one can.
What's the answer?
Yes. Uh, A.
Okay, good. Number two.
Um, donkey. I told already donkey.
Donkey. Yeah, to a galvanometer which has a resistance of 1 ohm. As 1 ohm has a full scale deflection when the current of 1 milliampere flows through it. A galvanometer can be modified to measure potential difference up to several volts. Which of the following modified arrangement is correct? So it cannot be donkey. If you're going to measure volt, right, this one is going to take a very low voltage. So the rest must be taken by this part. So it's either A or B or C. Right? We are going to measure several volts. So multiply determines the maximum voltage that can be measured. Okay? Several volts. They cannot be A. A is too small. Probably a few volts. Because it's the same as the resistance of the galvanometer.
Mm,
Okay?
okay.
Number three.
Donkey.
Okay, let's see. The graph shows a variation of potential difference across a resistor with current as a voltage, as a current. Current is 0.3 ampere, the power supplied to the resistor. So it's memorizing a formula. Go and estimate 0.23 is around here. Sorry, a bit blur.
Yep.
Estimate that it's about less than 6 volt. And use your P equals VI. Put your value inside. Doesn't matter about exact value because you are estimating on it. Then see which one is closer. Quite far away, so answer is B. Okay.
Okay.
This one.
A.
Right, let's see. The following diagram shows a circuit consisting of two balanced battery. Sorry, of two batteries. That's your one. Is the other one. I1, I2 are is your I1, so I2 value given respectively. Potential difference across P and Q is across here. So it means you have to find the current here through here. You can calculate from here if you want to. Okay, so as always the case, you apply Kirchhoff's current law first, either at P, that junction, or that junction there. So we are given I1 and I1 and I2. So you can calculate your I. Right, this one going in, these two coming out. So that's why you get a I1, I is just I1 plus I2. These two coming out, this is going in, I1. Then take your I2 across the other side. I1 is this value. I2 is this value. Got that? Then you got your I1, you can got your I, can calculate. I times your R. Okay, good. How about this one?
Sure, go back. Oh, so just V equals to IR only lah.
Yeah, that's all. You want to find potential difference across here. There's a current times the resistance.
Okay.
Okay, in 5 minutes time we'll stop. Then we'll go. We'll start a new topic.
Answer is A.
Let's see. Diagram shows the circuit. XY is a uniform wire. Potential when the galvanometer is connected at point P, that's a point P, and then point Q. That's the first part P, point Q. The balance length is 40. And connect to Q, then it's 44 cm. The value of R is okay. So what's the answer?
Ada tu aja A.
Let's see. Right, across that one, this one is 100 over R. 100 R is 40. And across, we are just using proportion, that's all. Right? Across this total resistance is, across this one is just that one there, 40. Across this total one is 44. We're just using that. Right? It's 100 plus R, that's what we're doing. Using potential divider question formula. Then this one we divide by 4. Divide by 4, you got 10 over 11. Then cross multiply. Cross multiply. Okay, good. That was fast. This one. Kirchhoff's law.
This one's the first law, right?
This one, don't think it's only the first law. It's probably the second law. Voltage law.
Boy.
Okay, let's see. We take it clockwise. You can choose clockwise or anti-clockwise. You right, your choice. So clockwise is going clockwise, and this is the right direction. This is the wrong direction. That's why we subtract. Then I1 passing through all that resistance plus internal resistance R1. Then this one, the current is going to the anti-clockwise, so we put a negative sign there. I2, this is through R2 and big R2. So R3, that's what we write here. Answer is B, okay? Good. Means you have been studying. Good. This one you have done before. You should be able to tell me the answer.
Wait, number 7?
Number 7 you have done correctly already.
No, there is a number 7. You straight went to number 8.
Oh, I think you leave it out first. I try to do it next week.
Oh, okay.
Didn't realize I missed it out. Oh, okay. Miss out one.
Oh. No, the question is they say which one following through lah for voltmeter and ammeter. Which one is high, which one is low. That's it only.
Never mind. We'll leave it for next week. How about number 8?
Donkey.
Done that before? No? Yeah, told ours is different one. This is 10 volt. This is 4. This is 2. This is 4. So it means that resistance and that resistance is the same. And then because this is 2, it means that R1 and R3, the resistance is double to R2. So you have to choose one. R1 and R3 is the same. R1 and R3 is the same. Then this one is half of that. That's all. Okay, I think we will stop here. Remember, Friday is your test. You cannot, you tell me the time, and then I expect you to do
No, there's no changing time.
focus. Make sure you do your focus question. You take your
Unless if there is a really big emergency, then only I will tell lah.
Yeah. Make sure
Considering
you
there's not that.
or sending instruction. One will focus on you. One device will focus on you. One will allow you to download the material.
Yeah, the laptop lah. My laptop and my
It's
phone.
your choice. It's your choice. So we will stop here, and then in 5 minutes time we will start a new Zoom. Okay. Can take a short break.
Okay. Yeah, thank you.